So our next theorem tells us the derivative of a constant is just 0. So this should make sense because if you have a constant function, the graph is just going to be a horizontal line. And we know horizontal lines have slope 0, and also we know that a horizontal line will be the same line as the tangent line. If you have a graph that's just a line, then the entire graph will be the same thing as the tangent line. So that means the slope of the tangent line will also be 0 everywhere. So the derivative equals 0. So we can look at an example real fast when to take the derivative of each of these things. I'm going to write it out, but you should know instantly that the derivative will equal 0 because we're taking derivatives of constants. So derivative, in part A, we have the derivative of 7. So 7 is a constant, so the derivative equals 0. In part B, we're taking the derivative of a constant. We're taking the derivative of pi squared. Remember, pi is just an irrational number, 3.14, and then a bunch more stuff after that, forever and ever. So if we square it, it's still going to be an irrational number, but it's just a number. It's just a constant. So the derivative of constant is just 0. So it just equals 0 when we take the derivative. Just because we use a fancy symbol to denote pi doesn't make it a variable. It's still a real number. Okay, our next derivative rule tells us if we're taking the derivative of a constant times a function, then we can just take that constant and pull it on the outside. And then we're just taking the derivative of the function. Let's find the following derivatives. So in part A, we have the derivative of 7 times x to the 4th. This is pretty much, we're just going to use the power rule, but we have the 7. So first of all, we can pull that 7 on the outside of the derivative. So we can write that as 7 times the derivative of x to the 4th. So we have the 7 on the outside, and now we're going to take the derivative of x to the 4th. Well, x to the 4th, we can use the power rule, so that 4 comes down as a coefficient. So we have 4 times x to the 4 minus 1 power, which of course just equals 3. So we have 7 times 4 to the x cubed. Now we can multiply the 7 and the 4, so then we just get 28x cubed. So for this example, I wrote out each step, but pretty soon you can just look at this derivative right here. You see you have the 4, so that's going to be 4 times 7 gives you 28, and then you do 4 minus 1, so you know you're going to have 28 to the x cubed. So you can do the derivative that fast once we get used to these rules. Okay, in part B, we want to take the derivative of negative 5 times the square root of x. First thing to do, move the negative 5, that's a constant, move it on the outside. So then we have negative 5 times the derivative of the square root of x. Now the square root of x, we need to rewrite that using the nth root rule. So that's the same thing as x to the 1/2 power. So now we have negative 5 times the derivative of x to the 1/2 power. Okay, now we're ready to take the derivative. So the negative 5, that's just hanging out on the outside. And then we take the derivative of x to the 1/2. So the 1/2 comes down as a coefficient. So then you have 1/2 times x to the 1/2 minus 1 power. So I can go ahead and multiply the negative 5 and the 1/2. So I get negative 5 over 2. And then times x, 1/2 minus 1 is negative 1/2. And I could leave my answer like that, or I could use a negative exponent rule to rewrite my answer like this, or I could use the nth root rule to rewrite my answer like this. So again, any one of these guys would be fine for your answer. Okay, in part C, we have the derivative of 1 over 5 times x squared. First, notice we have this 1/5 thing right here, so let's pull that out. That's a constant. So we have 1/5 times the derivative of 1 over x squared. Now we need to take this 1 over x squared and rewrite it like a power function. So now we use the negative exponent rule, and we can rewrite this as x to the negative 2 power. So we have 1/5 times the derivative of x to the negative 2. Okay, so the 1/5, that's just hanging out on the outside. Now let's take the derivative of x to the negative 2. Well, the negative 2, that comes down as the coefficient. So we have negative 2 times x to the negative 2 minus 1 power, which of course equals 3. So now we can rewrite this as negative 2/5 times x to the negative 3rd power. Or using the negative exponent rule, negative 2 over 5 times x cubed.